Bismillahirrahmanirrahim. Respected guests, speakers, conference committee, and participants, Assalamu alaikum. My name is Ahmad Ramagan. I'm a student at US Pakistan Center for Advanced Study in Energy, University of Engineering and Technology, Peshawar, Pakistan. I am going to present my conference paper with the title of Artificial Intelligence-Based Monitoring of Power Electronic Interfaces and Smart Grid. To proceeding of Third International Conference on Sustainable Energy Technology, the outline of the presentation having the heading Introduction, Aim and Objectives, Literature Reviews, Methodology, Result and Discussion, Conclusion, Future Work. Electric Power Grid. Traditionally, electrical grid mainly consists of power station, transmission lines, and transformers. They are highly prone to power failure. Energy demand is increasing at a faster rate than energy supply because of increase in population. With increase in energy costs, customer expectations are also increasing. With the advancement in technology, the power requirement around the globe is increases to fruitful level, which put extra load on grid. The existing grid cannot bear the load and do not provide the interface with distribution renewable energy sources. Building new lines and substation is not a solution to overcome energy shortfall by converting current power management system to automatic system. The goal is to establish a system that is healthy, efficient, stable, more reliable. A smart grid is intended to be more durable and self-healing. Smart grids. A smart grid is an electric power grid that can intelligently integrate the action of all users connected to it, generators, consumers, and those that do both in order to efficiently deliver sustainable, economic, and secure electricity supplies. The integration of environmental friendly renewable energy resources, particularly on distribution side, will change the grid dynamics. The advantage of integration of renewable energy sources into grid are is there is no emission of harmful gases in green energy generation, limiting the use of our primary energy resources. Power converter and inverter are contribute a necessary interface between renewable energy sources and distributed generation sources to electricity grid. Hence, their stable and reliable operation is necessary for healthy operation of future smart grid. For achieving this goal, I will focus on observing the condition of the ceiling filter capacitor of a typical DC to DC power converter interface utilized in smart grids. Artificial neural network algorithm of AI technique are considered to be applied for monitoring the condition of the ceiling capacitor of boost converter topology. Monitoring represents the first line of protection of any power system. In general, we are using power electronics in a lot of application from generation to consumption, and here are shown some different places where we are consuming a lot of electricity, and in between them we are putting the power electronic interfaces which enable efficient conversion of electricity and flexible control of electricity. Also, the interface are used for integration of renewable energy resources to electricity grid. When we talk about reliability, then we want to have a certain security that this equipment is operating in a certain lifetime according to specification. The objective of my presentation is modeling of DC to DC converter and MATLAB simulating, applying artificial neural network algorithm of AI technique. The health status of the ceiling capacitor should be known by estimating its capacitance and ASR value. A capacitor degradation level where the difference between the estimated value and the specified end of life threshold criteria is observed. An estimation of remaining useful life, early warning of the component failure. According to an industry survey on reliability in power converter system conducted, The semiconductor power devices and capacitors top the list of most fragile components, with each being voted by 34% and 20% of survey participants, respectively. The dual is followed by gate drives and connector. Both of them are believed to be fragile by more than 10% of the responder. Capacitors are found to be more susceptible to capacitance size, voltage stresses, current ripples, and frequency deviation. These characteristics give capacitor more upside potential to boost the reliability of a system, which frequently suffer from voltage and current ripple of different scales. Based on the investigation carried out in this research, the flowchart show the new method based on data and advanced algorithm solution and existing feedback signal without adding any hardware cost could avoid the critical shortcoming in the existing methodologies. The proposed DC to DC boost converter is modeled in matrix simulation environment. The table shows the rating of the DC to DC boost converter. According to degradation curve and based on the block diagram shown in this slide, end of life or threshold criteria is needed before going further and decide the health condition of capacitor. For electrolyte take capacitor, the widely accepted end of life criteria is 20% capacitance reduction or double of the equivalent series resistance. For film capacitor, a reduction of 2%, 2 to 5% capacitance may indicate the reach of end of life. The range in between the initial value of the capacitance RECR and the age value is the condition monitoring range. The selection of those end-of-life criteria are based on the capacitor degradation rate become considerably faster after the capacitor capacitance RECR reach the specified end-of-life criteria. The power electronic converter system may not function appropriately when the capacitance drop or the equivalent series resistance increase to specified level. The capacitance can be evaluated during onset of the switch when the equivalent series resistance effect is hidden by the load. The contribution of equivalent series resistance during conduction period can be neglected. This result is rather logical because the load resistance is hiding the effect of ECR, since they are connected in series and later is smaller enough. To perform the estimation, once the value of the gate signal is identified, it is possible to obtain the capacitor current as well. It is only necessary to apply the following expression of equation 1 and 2 during the conduction period. When the switch is off, the inductance of the inductor induces ripple current. The inductor current consists of a DC component ILDC and AC component ILAC, which can express by equation 3. Since the capacitor acts as an open circuit for DC source, only AC component of the inductor current will flow through the capacitor. For AC output component analysis, the circuit diagram can be further simplified. The output inductor current can be replaced by an AC current source ILAC, and a capacitor can be replaced by a simplified model of capacitor. Therefore, the output AC ripple voltage of the load resistor can be determined by equation 4. Equation 4 reveals that the output ripple voltage of the DC power converter is related to the ECR of the capacitor, the ripple current of the inductor, and the load resistor. Because of the demand of output voltage regulation, the ECR must be smaller than the load resistance. Under this assumption, equation 4 simplified and expressed by equation 5. It means that the equivalent series resistance of the capacitor is determined by output ripple voltage and the inductor ripple current. Artificial neural network is an AI technique that model human brain and consists of number number of artificial neuron in ANN tend to have fewer connections than biological neuron. Each neuron in artificial neural network receives a number of inputs. An activation function is applied to these inputs, which result in activation of neuron output value of neuron. An artificial neural network is specified by neuron model architecture learning algorithm. The neuron model is the information processing unit of neural network. Architecture is a set of neurons and links connecting neurons. Each link has a weight. A learning algorithm used for training the neural network by modifying the weight in order to model a particular learning task correctly on the training example. The aim is to obtain a neural network that is trained and generalized well. Using NF2 and MATLAB software, which are mostly applied for prediction and estimation problem, correlate a set of numeric target with a set of numeric input by neural network. The Leeuwenberg-Marquardt algorithm was employed in this training, which required extra memory but used less time to calculate. When correlation stops improving, the training will automatically terminate. In this research work, we developed two NN model, one for equivalence resist estimation, the second one for capacitor estimation. For equivalence resist estimation, we consider the input side current and output side voltage as input for NN model and select ACR as estimation target for the NN model having a single hidden layer and select 10 hidden layer neuron. For capacitor estimation, we consider the output side information of current and voltage as an input of the NN model and select capacitor as estimation target for the NN model having a single hidden layer and select 16 hidden layer neuron. Regulation factor play very important role during training process. A very strong correlation occurs when the regression factor close to 1. Arbitrary correlation may occur when the regression factor close to 0. For ACR estimation, the regression factor is equal to 0.99, which is close to 1. And for the capacitor estimation, the regression factor of ONN model is 0.992, which are also close to 1. In this slide, the simulation results are shown by waveform. The network are tested for validation purpose. Different type of capacitor are used and they are connected in parallel configuration by switch for the choice to switch them for different operation condition. So I run the simulation for 9 seconds. The time interval are divided in such a way at the first 3 seconds normal value of the capacitor are used. During 3 to 6 second time interval, the degraded capacitor value are used for testing the NN model estimation during degraded state. During the last 3 seconds, open circuit condition of capacitor are used to test the NN model, how they predict the open circuit state of the capacitor. On concluding, we can say that based on an investigation of the existing capacitor condition monitoring methodology, the presented work developed a new cost-effective method to monitor the change of the electrical parameter of capacitor for DC-link application in which less information are considered in order to achieve high accuracy for monitoring the healthy status of the ceiling capacitor by estimating its capacitance and ACR value that are easily implemented on existing resources and does not increase the hardware. In the future, we will focus on estimating the capacitor parameter during transit state. The proposed research work is conducted under balanced load condition. Considering unbalanced load condition is also intended as a future work. In the future, we will also investigate on new software algorithms such as clustering ANN and KNN algorithm for condition monitoring. Thank you so much.